Every server you run, every database, every application you put in the cloud has to live inside a network. And in AWS, that network has a name, VPC, Virtual Private Cloud. It sounds intimidating. Networking usually does. But VPC is built from just a few simple pieces, and once you can picture them, a huge amount of AWS suddenly makes sense. Think of this as learning to read the map of a city before you start building on it. Let's break it down. VPC stands for Virtual Private Cloud. It's your own private, isolated section of the AWS cloud, a network that belongs to you and nobody else. Here's the mental model. AWS is one enormous shared space used by millions of customers. A VPC is your fenced-off plot of land inside it. What you put in your VPC is yours, walled off from everyone else's, even though it all runs on the same underlying infrastructure. You create a VPC inside a region. That's a geographic location, like Ireland or Tokyo. And when you create it, you define its address range, the set of internal IP addresses your resources can use. Don't worry about the exact numbers. Just know that a VPC stakes out a private range of addresses that's all yours. That's your plot of land. Now let's divide it up. A VPC is usually too big to use as one undivided block, so you carve it into smaller pieces called subnets. A subnet is just a subdivision of your VPC's address range, like fencing off sections within your plot. And each subnet lives in one availability zone. So, what's an availability zone? It's a physically separate data center within your region. Each region has several. The reason they exist is resilience. If you spread your application across 2 or 3 availability zones, then a problem in one, a power cut, say, doesn't take down everything. The others keep running. So the relationship is, a region contains availability zones, and your subnets each sit inside one of them. Spreading subnets across zones is how you build something that stays up. Now here's a distinction that matters enormously. Subnets come in 2 flavors, public and private. A public subnet can reach and be reached from the internet. This is where you'd put things that need to face the outside world, like a web server that visitors connect to. A private subnet has no direct route to the internet. It's sealed off. This is where you put the things you want to protect, like your database, which should never be exposed directly to the public. This split is the heart of good cloud design, public-facing stuff out front, sensitive stuff tucked safely behind. Same plot of land, but some sections open to the street and some locked away in the back. What actually makes a subnet public or private? That comes down to 2 more pieces. The first piece is the internet gateway. An internet gateway is the single door between your entire VPC and the public internet. You attach one to your VPC, and it becomes the official entry and exit point for traffic going to and from the outside world. No internet gateway, no internet access. Your VPC is completely sealed. Attach one, and you've opened the possibility of connecting out. It's like the main gate in the fence around your plot. The gate existing doesn't mean every section can use it, though. And that's where the last piece comes in. The last building block is the route table. A route table is a set of rules that decides where network traffic should go. Every subnet is associated with one, and it acts like a signpost. Traffic headed here goes that way. And this is the actual secret behind public versus private subnets. A subnet is public because its route table has a rule sending internet-bound traffic to the internet gateway. A subnet is private simply because its route table has no such rule, so there's nowhere for that traffic to go. So it's not a magic label. A public subnet is just a subnet whose signpost points to the gate. Change the signpost and you change whether it can reach the world. Let's stack it up. You create a VPC, your private plot of land inside a region. You divide it into subnets, each sitting in an availability zone for resilience. Some subnets are public and some private. An internet gateway is the door to the outside world, and route tables are the signposts that decide which subnets actually use that door. That's the network everything else in AWS sits inside. Servers, databases, applications. They all live somewhere on this map. That's VPC, your own private network in the cloud, built from a handful of simple pieces. If networking just got a little less mysterious, hit subscribe. We're explaining AWS one service at a time. And let me know in the comments which service to break down next. See you in the next one.